let's talk about the types of alkanol, right? There are two ways you can classify alkanols. You can classify, so let's talk about alkanols. Alkanols are also called alcohol. So I said there are two criteria that we can use to classify alkanols. So let's look at the two criteria. Number one, you have classification based on, okay, so number one, the number of alkyl group present, alkyl group members present. Based on this classification, there are three types of alkanols. The first one is you have primary alkanol, which I can also call for first degree alkanol. Now for this primary alkanol, only one alkyl group is present. Okay? One hydrogen has been replaced. With an alkyl member. Now take note of this about this primary alkanol. It goes through two stages of oxidation. So it oxidizes partially to give alkanol, then completely to give alkanoic acid. So the complete oxidation will give alkanoic acid. What am I talking about? Let's see this example. So this is an alkanol. This is a primary alkanol, which this actually methanol. Okay, so one of the hydrogen, can you see there are three hydrogen attached to this alpha carbon. This is the alpha carbon. Why? Because it is directly carrying the functional group. So I remove this first one and I replace it with an alkyl member. So when you have one alkyl member directly attached to the carbon carrying the functional group, meaning that alkyl had replaced an hydrogen, you call this a primary alkanol. So this is one degree alkanol. So let's say an example, if I replace this with CH3, then I have this. If I name this now, this is called what? This is ethanol. So ethanol is an example of a primary alkanol. And this ethanol can go through two stages of oxidation. First will give me an alkanol, and in this case it will give me ethanol, and the complete will give me ethanoic acid. So number two, which is the secondary alkanol to the group. So let's see what secondary alkanol is. For secondary alkanol, two hydrogen atoms have been replaced by alkyl members. So what do I mean by that? Look at this. This is your alpha carbon, H. But in this situation for secondary, this has been replaced with an alkyl member, R, and this has been replaced, R. So I only have one hydrogen left. So for secondary, it is only one stage of oxidation that it can go through. So it goes through only one stage of oxidation. And what will it give? It gives ketone, which you also call alkanol. Alkanol. Okay, so that is the product of oxidation, ketone, alkanol. So let me give you an example of this secondary alkyl. So let's see the example of this secondary, e.g., if I replace this R with methyl, CH3COH, then I have CH3, then I have H. So how do I name this? This compound is actually, I can draw this as CH3CCH3. Then on my carbon 2, I have H and I have OH. Okay, so these are the same. This is an alkyl member, this is another alkyl member. Two alkyl members are attached to the alpha carbon. So this is a secondary alkyl. And the name of this compound is what? This is 1, 2, 3. Propan 2-ol. Or 2-propanol, okay? So this is propan 2-ol because the functional group is on carbon 2. So propan 2-ol is a secondary alkyl. And remember we said it will go through just one stage of oxidation, that's the removal of this hydrogen, and it will give you a ketone, propan 2-ol. And the third one is the tertiary alkanol. So for this tertiary alkanol, all the hydrogen attached to the alpha carbon have been completely replaced by alkyl members. So there are three alkyl members attached to the alpha carbon. So what is one characteristics of this? It does not undergo any form of oxidation. It does not undergo oxidation at all. So it does not undergo oxidation at all. So I'm going to give you an example. So let's say example of tertiary alkanol. You have, these are three alkyl group attached. So an example is your COH, CH3, CH3, CH3. So what's the name of this? This is 2-methyl. So if I want to I can redraw this for easy naming. I have CH3, C, CH3, OH, CH3. These are the same. This is one alkyl group, another, and the third alkyl member attached to the alpha carbon. So this can be, I can name this as 1, 2, 3. So this is 2-methyl propan 2-ol. 2-methyl because of carbon 2, I have the methyl. Propan because 1, 2, 3, and then 2-ol because of carbon 2, I have the functional group. So this is a tertiary alkanol. And because no hydrogen is available, this will not undergo any form of oxidation. So that is that. About the second type of classification, the criteria. So the second classification is classification based on the number of hydroxyl group, the functional group OH present. Okay? Second criteria, classification based on number of hydroxyl present. So the first is called monohydric. Monohydric, it means one hydroxy group is present.